Greetings, fellow mathematicians. We're going to take a look at a surface area problem. Now, this is a really good problem because there's a little bit of work for the setup and evaluation. Before we get to the setup, let's go ahead and take a look at our formula for the surface area. We take a curve of the form y equals f of x, and then we're going to rotate that about the x-axis. Now, your formula is very straightforward. You have your arc length term, the square root of 1 plus the first derivative squared, but we're multiplying by a factor of f of x, the function. So in some sense, these problems are straightforward plug and chug problems. You just take the equation of your curve and plug it in, realizing you have f of x out front, don't forget that, and f prime of x inside the square root. All right, if we take a look at the problem here, we pretty much have everything we need. We have the equation of our curve, y equals 2 times square root of x, and that is our f of x here. So let's write that down. F of x is 2 times square root of x. To differentiate that, I'm going to rewrite this as x to the 1/2 power. No problem, and if you differentiate that to get f prime of x, bring the 1/2 down, that'll cancel with the 2, leaving you with x to the negative 1/2. And you can rewrite that as 1 over the square root of x. All right, so we need to plug in f of x and f prime. Now let's go ahead and simplify the arc length term here. So in other words, 1 plus the first derivative squared, and that is pretty simple here. Notice squaring a square root, that'll cancel out, and this will simplify the part inside the square root to 1 plus 1 over x. All right, well, we have pretty much the arc length term. We just need to multiply that by f of x and then integrate that. Also, don't forget about your factor of 2 pi. So let's set up the surface area integral here. That's going to be an integral from 1 to 3. We have a factor of 2 pi. We're multiplying that by f of x. And we have the square root of 1 plus the first derivative squared, which we just simplified here to 1 plus 1 over x. And that's all inside a square root. All right, now we can clean this up a little bit. We have a factor of 4 pi, which I can pull out in front of the integral. All right, but we're left with square root of x times the square root of 1 plus 1 over x. And this is where we might seem to be stuck because that looks like a pretty difficult integral to evaluate. Now, we can actually simplify that with one of the most important techniques for finding antiderivatives, rewrite. In other words, just rewrite the function that you're integrating, and you can probably integrate it. And here, what we're going to be using is a basic property of square roots. If we have square root of a times square root of b, we can write that as the square root of the product. Now, it's worth pointing out this basic product rule for radicals and square roots, it only works if a and b are both non-negative. All right, and it's worth mentioning here that the insides, x and 1 plus 1 over x, are positive since your values of x are between 1 and 3. So in other words, we can go ahead and apply that property here, and we should get an integral that looks a lot simpler. All right, I'm going to think of that as now a single square root of x times 1 plus 1 over x. And the key step for why rewriting works here, distribute that x through the parentheses. And we're going to get the square root of x. And the key step here, that factor of x, when you distribute it to 1 over x, that will cancel out to 1. All right, and there we go. That is the setup, and that is as far as we can take it for both setting up the integral and simplifying it. So from here, we're going to turn to evaluating this with a straightforward u substitution. For our substitution, we're going to choose u as x plus 1. The work here is going to be very straightforward. So with u as x plus 1, your differential du comes out to 1 dx, which we'll just write as dx. And since we're doing a substitution with a definite integral, let's go ahead and change or convert our limits. So we'll convert from x limits 1 to 3 to new u limits using our substitution. Just go ahead and plug in x as 1, you'll get u as 2. Plug in x as 3, you'll get u as 4. All right, from here, it should be very simple to convert this integral from x to u. We'll keep our factor of 4 pi out front. And we now have an integral going from 2 to 4. We're integrating with respect to u. And we can rewrite the function here in terms of u as the square root of u, which we'll rewrite as u to the 1/2. That way we can use the basic power rule. All right, from here, just the basic power rule, add 1 to that exponent, you'll get u to the 3/2, divide by that new power, divide by 3/2, same thing as multiplying by the reciprocal, 2/3. We'll keep our factor of 4 pi there. And then for your antiderivative, you get 2/3 times u to the 3/2 power. And now we're going to evaluate that from u equals 2 to u equals 4. All right, before we do that, let's go ahead and clean up the fractions here. You can write this as 8 pi over 3. And if you go ahead and plug in u is 4 and u is 2 and subtract, you'll get 4 to the 3/2 minus 2 to the 3/2. And that is the exact value for the surface area. Now, you could leave your answer as this, but it actually can be cleaned up a little bit. And first, let's go to the 4 to the 3/2 power. We're going to recognize the 1/2 power as a square root. Square root of 4, that's 2. So let's split this up as 4 to the 1/2 power. Then we'll cube that. Inside the parentheses, that's the square root of 4, which is 2. 2 cubed, that comes out to 8, which is pretty nice. All right, 2 to the 3/2 power, that's not going to give us as nice a value. It'll still be a square root or radical, but at least we can, again, simplify it a little bit. All right, I'm going to split up the 3/2 power as 1 plus 1/2. And if you notice there, 2 to the 1/2, that's the square root of 2, and we get 2 to the 1, which is just 2, which is pretty nice. So we can write this whole term, 2 to the 3/2, as 2 times square root of 2. If we go ahead and plug those in for rewriting our answer here, all right, 4 to the 3/2, we're writing that as 8, and 2 to the 3/2, we're rewriting that as 2 times square root of 2. And the last step to clean that up, notice you can factor out a common factor of 2 from inside the parentheses, and you can write your final answer as 16 pi over 3 times 4 minus square root of 2. That's a pretty nice, clean-looking answer. But this one is certainly fine and full credit too. All right, hope you enjoyed this straightforward surface area problem. Straightforward to set it up, and then also straightforward to evaluate it. If you're enjoying the content, support the channel, like and subscribe.